Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथरे मु ऑलरेडी प्लस 2 सेकंड ईयर सिलेबस कंप्लीट कर सारछि एबे मु प्लस 3 CBCS ऑनलाइन क्लासेस रो वीडियोज गुडा अपलोड करिवि जदि भल लागिला ताले लाइक कर देबो एवं सब्सक्राइब कर देबो जो वीडियोज गुडा मु अपलोड करिवि तार नोटिफिकेशन पई एठी बेल आइकन को ऑल रे सेट कर देबो गोटे इंपोर्टेंट जिंस वीडियोज रो ऊपर एठी जो 3 डॉट्स देखुछो तार क्वालिटी एठी देखो बाय डिफॉल्ट 360 अछि तमे ताकू बढ़े मध्ये परिबो एठी एडवांस रे क्लिक करी तमे रिजोल्यूशन बढ़े परिबो प्रति वीडियोज रे मु पीडीएफ लिंक देबी ताकू एठी ड्रॉप डाउन लिस्ट रो तमे क्लिक करी डाउनलोड मध्ये करि परिबो पीडीएफ को लास्ट रे एठी जो मोर चैनल नेम अछि याकू क्लिक करी तमे एठी प्ले लिस्ट को जाई मु प्रति वीडियोज को यूनिट वाइज एज पर सिलेबस सजाई की रखिथिबी तमे सर्च करि परिबो ओके थैंक यू हेलो स्टूडेंट्स आज रो टॉपिक रे हमें जूल-थॉम्सन पोरस प्लग एक्सपेरिमेंट तापरे जूल-थॉम्सन कूलिंग एंड देन टेम्परेचर ऑफ इन्वर्शन विषय रे पढ़िबा तो देख प्रथमे आमे जानि नेबा जे व्हाट इज जूल-थॉम्सन इफेक्ट तो आमे देखिला जे रियल गैस एक्चुअली डिफर करे फ्रॉम आइडियल गैस विथ रेस्पेक्ट टू इट्स मॉलिक्यूलर फोर्सेस एक्चुअली रियल गैस रे इंटर मॉलिक्यूलर फोर्स ऑफ अट्रैक्शन एग्जिस्ट करे किंतु आइडियल गैस रे एई फोर्सटा एग्जिस्ट करे नाही ओके thus the internal energy of a real gas which is the sum of total kinetic and potential energy of the molecules and here the potential energy depends upon the molecular attraction जोटा कि डिपेंड करे molecular separation उपरे molecule भितरे जो separation टा रहउची माने करो गोटे गैस आमे नउचू तार जदी डेंसिटी बेसी अछि माने वॉल्यूम कम अछि ताले molecule माने बहुत पाखरे पाखरे थिबे सिमिलरली जदि गैस रो डेंसिटी कम अछि माने वॉल्यूम बेसी अछि ताले एबे मॉलिक्यूल भितर सेपरेशन टा बेसी रहिबो okay so this molecular separation depends upon the volume of the gas and therefore a change in volume of the gas should result in a change in internal energy आ जदि internal energy change हला ताले आमे जानिचु it will change the temperature okay अच्छा Joule actually in the year 1833 he tried to verify this temperature difference by forcing compressed air from a vessel into an evacuated vessel through a narrow orifice but जोटा हमें जूल्स एक्सपेरिमेंट देखुला but he could not get accurate results due to the insensitivity of the apparatus तेणु ताकू मॉडिफाई पुणी करिले later on in the year 1852 प्राय आज को 150 वर्ष पूर्वे where he was working in collaboration with Lord Kelvin देखो ये Lord Kelvin को हमें विलियम थॉम्सन ओके विलियम थॉम्सन जी लॉर्ड केल्विन भी सी ओके सो लॉर्ड केल्विन को संगे कोलाबोरेशन करिकी से एई जो apparatus को पुणी मॉडिफाई कले ही डिवाइज्ड अ वेरी सेंसिटिव टेक्निक फॉर getting the result and it is known as porous plug experiment okay which established beyond doubt the existence of intermolecular attraction so intermolecular attraction exist करूची बोली तार experimental proof टा एई porous plug experiment रू जणा गला okay so ए जो Joule-Thomson बा Joule-Kelvin effect actually it is the phenomenon by virtue of which a gas in general undergoes a change in temperature on escaping through a porous plug एठी porous plug कहले बुझिबा हमें it has number of pores बा छोटो छोटो रंध्र थाए जहाँ भीतर देई gas molecule easily pass करि परिबो okay now let us see the principle actually Joule-Thomson effect is based upon the principle that as a gas well insulated from the surrounding माने insulated हेगला so heat constant रहिला okay so it escapes through a porous plug and the enthalpy of the system remains the same constant रहिबो at initial and final stages okay तो जदि U1 P1 V1 हेगला हमरो internal energy pressure आ volume before expansion माने initially आ U2 P2 V2 हेगला corresponding values after expansion final value ताले as per the above principle U1 plus P1 V1 equal to U2 plus P2 V2 that is in terms of enthalpy H1 must be equal to H2 okay now let us see the Joule-Thomson Porous plug experiment. Okay, एटी याकू डायरेक्ट आमे फिगर रे बुझिबा. So देखो एटी फिगर रे you can see the apparatus of this Joule-Thomson Porous plug experiment. So obviously it consists of a porous plug, this one which is capital G, जोटा कॉटन वूल बा सिल्क फाइबर रे तैयारी, सो दैट जेमती कहली गैस मॉलिक्यूल्स या भितर थिबा जो छोटो छोटो रंध्र बा पोर्स अछि इट कैन इजीली पास थ्रू. Now this porous plug is held in position between two brass perforated disc small d. Perforated means a disc को भी हमें छोटो छोटो कणा करथिबा by means of piercing. Thereafter it is enclosed in an wooden box tube capital B on both sides. Okay, so wood होउची bad conductor of heat, so that याकू जदि आमे wooden box tube रे enclose कर रखिला ताले एटा thermally insulated हे जिवो. Okay, now the wooden box cylinders actually it is fitted on both sides of copper tube C and C. Okay, thereafter it is surrounded by a brass or asbestos casting A and A on both sides. Okay, ये जो bolt है की अच्छी. Okay, which is filled with cotton wool to serve as thermal insulator. Okay, now the lower copper tube, ये जो lower part तुम देखुछ, it is connected to the compressor pump. Okay, compression pump ये तले जो अच्छी एटा होची compression pump. एठी गुटे देखो तुम piston लागिची. Okay, so that आमे गैस को compress करि परिबा. And it is connected with the copper tube by means of this spiral tube. Okay, ये जो spiral tube देकी एटा connection हेची. Okay, अच्छा तापरे एबे देखो दुईटा platinum resistance thermometer आमे नेबा T1 and T2 for measuring the temperature of lower and upper end of the copper tube. Okay, so एठी ये केमती measure करिवो ना एठी coil अछि देखो. Okay, so coil टा जेतेबेले heat हबो with respect to that we can measure the temperature. So T1 को आमे lower copper tube रे रखिबा, T2 को upper copper tube रे. एठी तळे देखो अछि गुटे compressor pump. Okay, या भितरे थिबा internal pressure को आमे measure करि परिबा by using this pressure gauge or manometer. A final pressure को आमे नेबा equal to that of your atmospheric pressure. अच्छा एई संपूर्ण जो apparatus टाकू आमे कोन करिबा एठी देखो पानी रे एटा रखा जाईछि. Okay, it is immersed in water bath in order to keep the temperature constant. Okay, now the experiment is repeated for different pressure differences on both sides of porous plug for different gases over a wide range of temperature. Okay, अच्छा जेतेबेले आमे एठी compress करूछु by means of this piston, it is allowed to pass through the porous plug for about an hour. पाखापाखि गोटे घंटा पाखापाखि आमे एई गैस को एई porous plug देकी पास करेबा till we are arrived at a steady state. Okay, due to now the decrease of pressure, the gas expands while passing through the pores of the porous plug. Okay, because जेतेबेले gas रो expansion हबो due to the decreased pressure, then एबे कोन हबो steady state आडको ये जिवो. Now if this plug is not used, suppose ए plug टा हमें यूज करू न थांता ताले कोन हबो, the gas would rush forward. Okay, संगे संगे ये आकु पळेबो, the gas would rush forward with the creation of eddy currents. आ ए जो eddy current आमे जानिचु एहा द्वारा एनर्जी रो लॉस हबो in form of heat. Okay, the porous plug will provide a large number of long and narrow path. एहा भीतर दे narrow path रे a gas molecule pass करिवो, and while passing through these paths the molecules of the gas are pulled apart due to the expansion. आमे जानिचु expansion हला means molecule भितरे separation बढ़िबो, so that they are pulled apart. Okay, so slow expansion रे एई भलिया होउची. So एई process को आमे कहिबा कोन ना throttling, THROTTLING. ओके, ए प्रोसेस को हमें थ्रोटलिंग बोली की कहिबा. सो ये हला ए जो एक्सपेरिमेंटल सेटअप. सो ए थ्रू कोन कोन रिजल्ट्स मिलिला ताको एबे हमें डिस्कशन करिबा. ओके, सो ए जो जूल Joule-Thomson रो porous plug experiment आमे देखिला actually एटा perform करा जाइथिला for a number of gases like air, oxygen, nitrogen, carbon dioxide, hydrogen, helium, etc. over a wide range of temperature and pressure, and their results are summarized as below. देखो एटी first point रे कहूची all gases suffer a change in temperature on passing through the porous plug. Second point कहला ए जो temperature change आसुची it is directly proportional to the pressure difference on both sides of porous plug, and more will be the pressure difference, more will be the temperature drop. Okay, third point रे जदि sufficiently low ହେଇଗଲା temperature ताले all gases will show cooling effect. Okay, our ordinary temperature by room temperature रे in most of the gases cooling effect ଦେଖାଗଲା except in case of hydrogen and helium जोटा कि heating effect देखैला. Okay, then fifth point रे देखो ये कहूची the fall in temperature per atmosphere difference of pressure decreases as the initial temperature of gas is increased. Okay, and it becomes zero at a particular temperature. This is very important point. गोटे particular temperature रे एटा कमी कमी की zero हो गला pressure टा. Okay, which is different for each gas. प्रत्येक गैस में अलगा अलगा गोटे constant temperature रे pressure difference टा zero हो जाउची. And above this temperature again there is no more fall but rather rise in temperature. So एई जो temperature जो उतरे की Joule-Thomson effect टा reverse करी जाउची तार sign को माने temperature at which the cooling effect becomes heating effect because temperature rise कला after this temperature. So एई temperature को आमे कहिबा कोन ना temperature of inversion. Okay, so Joule-Thomson effect या को आमे Joule-Kelvin effect भी कहि परिबा. एबे देखिबा ए जो temperature of inversion आमे कहला तार definition जदि आमे देखिबा actually the temperature at which the Joule-Thomson effect is zero and its changes sign is known as the temperature of inversion. So यार symbol हला capital T तले subscript एठी small I दबा I for inversion. At this temperature आपको एटा derive करिबा हमें 2a by RTI equal to small b. एठी small a और b हेगला van der Waals constant. Okay, so that Ti रो value आसिला 2a by RB. So एठी देखो condition दउची जदि temperature टा inversion temperature रू कम अछि then obviously cooling will take place, आ जदि बेसी अछि ताले heating will take place. आउ केतरा example Ti रो value in case of helium it is 35 Kelvin, then in case of hydrogen it is 193 Kelvin. आको बढ़िबा, let us now see the Joule-Thomson cooling or regenerative cooling. So हमें देखिला in case of hydrogen and helium एठी cooling produce होनी rather heating was observed at room temperature. काहे कि एमती होउची because हमें जानिला जे hydrogen आउ helium पई actually room temperature टा होउची far beyond the temperature of inversion. Okay, hydrogen पई minus 80 degree Celsius होउची temperature of inversion that is 193 degree Kelvin. आउ helium पई सेदी भली minus 258 degree Celsius or 35 degree Kelvin. Suppose helium को आमे जदि pass करेला through porous plug at a temperature lower than its temperature of inversion that is minus 258 degree Celsius, ताहले obviously it will also show the cooling effect. So this means any gas below its temperature of inversion will show a cooling effect when it is passed through a porous plug or throttle valve. So याकू आमे regenerative cooling or simply Joule-Kelvin or Joule-Thomson cooling बोली की कहिबा. आ एई प्रिंसिपल को यूज करा जाए for liquefaction of permanent gases like that of your nitrogen, oxygen, hydrogen and helium. Okay, now let us see the theory of porous plug experiment from which we can estimate the Joule-Thomson cooling. So theory रे जो आमे कौन करिबा यार simple arrangement ए Joule-Thomson porous plug experiment रो आगो देखिबा फिगर रे as shown in this figure. As you can see देखो एटी फिगर रे this region is having very low volume as compared to this region. That means this will have higher pressure and this will have lower pressure, right? So आमे कौन करिबा ए गैस को पास करिबा from higher to lower pressure through a porous plug, right? So that a जो large pressure difference रहिला, due to this the gas flows through the fine pores जोटा ए porous plug भितरे अछि and becomes throttle or wire drawn. That means the molecules of the gas are further drawn apart from one another. Okay, so आमे consider करिबा 1 gram molecule of a gas which is passing from left to right, okay, through this porous plug. Suppose आमे कहला P1 आउ V1 ये हे गला pressure and volume of your left side. Similarly P2 and V2 हे गला pressure and volume of the right side. Okay, now एठी आमे piston को देखो A एई piston को move करेबा through a certain distance, suppose dx. Okay, ए dx distance आमे piston को move कला. अच्छा तापरे एठी right side रे देखो बड़ piston टा अछि B. So this B will also move. Suppose एटार मूवमेंट जदि आमे देखिबा ताले obviously same distance ये move करिवो dx. Okay, so the work done on the gas by the piston A will be how much? P1 A1 dx. Okay, एठी A1 कहले आमे एरिया को बुझिबा. Okay, so P1 A1 dx, that means P1 V1, right? Similarly the work done by the gas on the piston B, this will be P2 A2 होची ए एरिया टा into dx, that means P2 V2. Okay, thus the net external work done by the gas केते हिजिवो? Obviously P2 V2 minus P1 V1. Okay, so एठी कहूची जदि small w हे गला work done by the gas in separating the molecules against their intermolecular attraction, ताले total amount of work done by the gas केते हिजिवो ना P2 V2 minus P1 V1 plus this small w. Now no heat is gained or lost to the surrounding because it is insulated, right? So there are three possible cases. First case है below the boil temperature where P1 V1 is less than P2 V2 because boil temperature रू कम जदि रहुची ताहले final work done टा बेसी हेबो, right? So এই case रे कोन हेबो P2 V2 minus P1 V1 will be positive obviously. Then this small w must be either positive or 0. Thus a net positive amount of work is done by the gas and there must be cooling. Okay, so jodi positive hela net work done, there must be a cooling when the gas is passing through the porous plug. Second case hochi at the boil temperature. Okay, जेतेबेले temperature टा equal to that of your boil temperature हे जिवो, if P1 is not very high, then we will have as per Boyle's law P1 V1 equal to P2 V2 because the product of pressure and volume will remain constant. So P2 V2 minus P1 V1 will be equal to 0. ताले total work done by the gas will be equal to that of this small w. Therefore the cooling effect at this temperature is only due to the work done by the gas in overcoming the intermolecular attraction. Okay, ये गला second case. एबे देखिबा third case एठी कहूची above the boil temperature. So above the boil temperature हे गले एबे P1 V1 will be greater than P2 V2 so that the final work done will be less. That means P2 V2 minus P1 V1 will be negative. So एबे এই জায়গারে কুলিং হেবো না হিটিং হেবো সেই जो effect depend करिवो whether your P2 V2 minus P1 V1 is greater or less than small w. देखो आमे total work done टा पाई थिला केते P2 V2 minus P1 V1 plus w एतकी पाई थिला. अच्छा याको आमे लेखि परिबा w minus P1 V1 minus P2 V2, right? So एबे याको आमे इंटरचेंज कर दिला, right? So एबे देखो ए जो टोटल वर्क डन এটা যেତେବେଳେ পজিটিভ হব দ্যাট মিন্স কুলিং হব আর যদি নেগেটিভ হব তাহলে হিটিং হব সো এই যে রিলেসন সেকেন্ড রিলেসন রু আমি জানিବାକୁ পাউଛୁ যদি W less than P1 V1 minus P2 V2 ହେଲା ତାହେଲେ କ୍ୱାଣ୍ଟିଟିଟା ପଜିଟିଭ୍ ଆସିବ ଦ୍ୟାଟ୍ ମିନ୍ସ କୁଲିଂ ୱିଲ୍ ବି ଅବଜର୍ଭଡ୍ ସିମିଲାରଲି ଯଦି W less than P1 V1 minus P2 V2 ହେଲା ତାହେଲେ total quantity ଟା negative ଆସିଯିବ and heating will be observed. Okay, thus the cooling or heating of a gas due to free expansion through a porous block from high pressure to low pressure will depend on two factors. Number one, the deviation from Boyle's law, and number two, the work done, which is small w, in overcoming the intermolecular attractions. Okay, so ये है Joule-Thomson cooling. Finally, let us now see the Joule-Kelvin effect, where we will study the temperature of inversion. Okay, देख ये आम गोटे भेंडरवाल्स गैस को कंसीडर करवा आउ एज पर भेंडरवाल्स इक्वेशन ऑफ स्टेट आम जाचु P plus A by V square into V minus B equal to RT. Right, now the attractive forces between the molecules are equivalent to this A by V square, which is nothing but the internal pressure. Okay, suppose gas ta expand करुची from volume V1 to V2, then the work done in overcoming the intermolecular attraction याकु लिखि परिबा हमें small w is integration V1 to V2 of PdV. P जगह आम पुट करवा A by V square. So आपको आम जदि सॉल्व करी जीवा will arrive at minus A by V2 plus A by V1. So एटी V1 आउ V2 जदि रिप्रेजेंट करुची ग्राम मोलिकुलर वॉल्यूम्स on the high and low pressure sides respectively, then the external work done by the gas केते हबो P2 V2 minus P1 V1. Hence the total work done by the gas ऊपर जोटा हमें पाइथिला capital W is a quantity ऊपर पाइथिला P2 V2 minus P1 V1 plus small w रो ए वैल्यूटा हमें पुट कर देबा ई जगह रे. Okay, now the van der Waals equation of state for a gas जोटा हमें कहूला P plus A by V square into V minus B equal to RT. Okay, एबे ए दुईटा जाक टर्म को आमे मल्टीप्लाई कर देबा विल हैव लाइक दिस. सो P V रो वैल्यू आमे पाइबा दिस मच. एठी आमे नेग्लेक्ट करूछु AB by V square because the product AB is very less as compared to V square. Okay, so P V रो जो एठी आमे वैल्यू पाइला ऊपर देखो टोटल वर्क डन रो एक्सप्रेशन रे आमे P2 V2 P1 V1 पाइथिला. अकॉर्डिंगली आमे याकू लिखि परिबा. सो P V रो वैल्यू ए हिसाब रे आमे पाइछु. सो P2 V2 will be like this, P1 V1 will be like this. आ एटा जोटा रेस्ट टर्म को एज इट इज लिखि दबा. तो याकू सॉल्व करले टोटल वर्क डन W रो वैल्यू आमे पाइबा लाइक दिस. ओके, सो आकू देखो एबे V1 as per the gas equation V1 रो वैल्यू आमे जानिछु it is RT by P1 because P1 V1 equal to RT. Similarly V2 will be RT by P2. तो याको आमे रिप्लेस करि परिबा. ओके, अगेन वी कैलकुलेट, वी सॉल्व इट एंड W रो वैल्यू एबे आसिला P1 minus P2 into 2A by RT minus B. Now suppose the fall in temperature is delta T. ताले in terms of your heat हमें वर्क को एक्सप्रेस करू W equal to JH. ओके, सो एठी हमें याकू लिखि देला हीट को mCp delta T. Cp है गला स्पेसिफिक हीट एट कांस्टेंट प्रेशर. ओके, आउ m होची एठी ग्राम मोलिकुलर वेट ऑफ द गैस. ताले याकू जदि मल्टीप्लाई कर देला then JmCp delta T, which is the total work done, will be this much P1 minus P2 into 2A by RT minus B, or delta T will be this much. JmCp को हमें आरपट को नहीं करला. Okay, now let us discuss some of the conditions. First होची जेहेतु P1 minus P2 is positive because हमें high pressure रू low pressure को जाऊचु. So initial pressure is greater than that of the final pressure. So P1 minus P2 is positive. So delta T will be positive if 2A by RT minus B is positive एज पर द एक्सप्रेशन देखि पारथबो एठी सो जदि एटा पॉजिटिव हैला that means 2a by rt will be greater than b or t will be less than 2a by rb. Okay, therefore the cooling will take place if the temperature of the gas is less than your 2a by rb. तापर सेकंड कंडीशन कहूची डेल्टा टी रो वैल्यू जदि 0 हैला ताले से ऊपर जो आमे एक्सप्रेशन पाइथिला सेथरु 2a by rt minus b यार वैल्यू ही 0 हबाकू पड़िबो दैट मीन्स t रो वैल्यू आसीबो इक्वल टू 2a by rb which is nothing but the temperature of inversion. Okay, that is ti. So ti को आमे लिखिला equal to 2a by rb. आ थर्ड कंडीशन रे जदि डेल्टा टी नेगेटिव आछी दैट मीन्स 2a by rt minus b will be negative. That means b must be greater than 2a by rt or t must be greater than 2a by rb or t must be greater than the temperature of inversion. So the heating will take place if the temperature of the gas is more than that of the temperature of inversion ti. Okay, अच्छा तापरे एठी यार जो फाइनल रिजल्ट आमे पाइला ताकू देखो एठी पॉइंट वाइज लिखाई छे फर्स्ट पॉइंट रे ये कहूची इफ द गैस इज at a temperature of inversion then there will be no cooling or heating, okay, when it is passed through the porous plug. मने रख टेम्परेचर ऑफ इन्वर्सन रे गैस जदि अछि किछि भी कूलिंग किंबा हीटिंग हेबो नाही. सेकंड पॉइंट रे कहूची इफ द गैस इज एट ए टेम्परेचर लेस देन your temperature of inversion ताहले cooling हेबो. Okay, cooling will take place when it is passed through a porous plug. आ याको हमें regenerative cooling और Joule Kelvin cooling बा Joule-Thomson cooling बोली की कहिबा. And this principle has been used in case of your liquefaction of permanent gases. Okay, जोटा already हमें discussion करला permanent gases like your nitrogen, oxygen, hydrogen and helium. थर्ड पॉइंट रे कहूची जदि गैस रो टेम्परेचर ग्रेटर देन द टेम्परेचर ऑफ इन्वर्सन होउची ताहले कूलिंग न होई कि हीटिंग प्रोड्यूस हबो. ओके, हीटिंग विल बी ऑब्जर्व्ड व्हेन द गैस इज पास्ड थ्रू द पोरस प्लग. ओके, फाइनली let us see the relation between the boil temperature, temperature of inversion and the critical temperature. Okay, this is for the case of a real gas. तो टेम्परेचर ऑफ इन्वर्सन जो टी आई रो वैल्यू हमें पाइला 2a by rb, बॉइल टेम्परेचर रो वैल्यू tb या को हमें जानिछु a by rb आ क्रिटिकल टेम्परेचर रो वैल्यू हमें जानिछु tc which is 8a by 27 rb. सो ए तीनटा रिलेशन रु हमें देखुछु जे ti must be equal to 2 times of tb. नाउ ti by tc जदि हमें बाहर करिबा ताले यार वैल्यूटा आसीबो रेशियो 27 by 4 which is around 6.75. But however experimental value ti by tc ro for actual gases is just less than 6. So हमें देखिला ये जो temperature of inversion ti is much higher than the critical temperature tc because ये जो equation रू हमें देखुछु ti is nearly 6 times that of your tc. For example, in case of your hydrogen, Ti ro value 190 Kelvin, but Tc ro value 33 Kelvin. So as Ti is greater than or equal to Tc, so the methods which are employing the regenerative cooling, that is your Joule Kelvin cooling, are preferred to those employing the initial cooling of the gas below the critical temperature. आ गोटे जिनस भी ये जो रेशियो Ti by Tc जेहेतु केवल गोटे नंबर आछि around 6.75 from the above equation, so this ratio is not depending upon the nature of the gas. Okay, thank you.